Hello guys, welcome to our video of the playlist called C# for Beginners. So, quick question to start today off. Every variable we've made so far has held some kind of data, right? A number, string, an object, but here's something that might sound a little strange at first. What if a variable could hold a method itself, not the result of calling it, the actual method ready to be called later, almost like a piece of code you can pass around like any other value. That might sound abstract right now, but trust me, by the end of this lesson, you're gonna see this concept absolutely everywhere in C# code. Event handlers, LINQ, which we'll cover soon, async programming, all of it leans on what we're learning today. This is called a delegate. Let's dig in. So delegate is a basically type that represents a method signature, meaning what parameters it takes and what it returns rather than representing actual data like int or string do. Let's define one. Delegate void greet string name. Okay, let's slow down on this because the syntax looks a little unusual at first. Delegate, that's the keyword telling C# I'm defining a new delegate type, then void, that's the return type any method matching is delegate must have. Then greet delegate, just the name we are giving this delegate type, same as naming class. And finally string name, the parameter list any matching methods need to have. So really all this line says is I am creating a type called greetDelegate, and it can hold any method that takes a single string and returns nothing. It does not actually point to a method yet, it's just describing the shape a method needs to have to qualify. Okay, so now let's actually put a real method into one of these. Okay, void greet formally string name console.writeLine good day name. Okay, void greet casually string console.writeLine hey him what's up here greet delegate greeter equal greet formally greeter so Alex. Okay, look at what's happening here. Greet delegate greeter equals greet formally. Notice, we are not calling greet formally here. No parentheses at all. We are literally assigning a method itself into our delegate variable, a greeter. And then greeter Alex calling a greeter actually runs whichever method it's currently pointing to. And here's the really interesting part. Look at the second half. We just reassigned greeter to a point completely different method, greet casually. Look, greet greeter equally, greet casually, and then greeter maybe John. Let's run this. Oops. Clear. .NET run. Yep. Hey, good day, Alex. And hey, John, what's up? Are you seeing the difference? We just reassigned the greeter point to at a completely different method by just calling the here greet casually. Okay, and calling it again runs totally different code, even though we are calling the exact same variable greeter both times. Yes, this is genuinely the core idea at Delegate. Let you swap out which code runs dynamically at runtime rather than being fixed when you write the program. Okay, so defining your own delegate type every single time is a bit of extra work, honestly, and it turns out C# actually gives us some built-in, ready-made delegate types for extremely common situations, so you don't have to. The first one is called action. Let me show it. Action, string, greet. Oops, didn't need to delete this one actually. Action, okay, string, greet equal greet formally. Oh, greet formally. Okay, and greet will be Alex. Okay, so let's run this. Good day, Alex. Okay, let's clear the console. And then let's try this one. Action, say hello. Good Alex, good day, Alex, and hello. See, no custom delegate keyword here. Needed. We don't need this. Whenever we call the action, we don't need a custom delegate keyword. Action string is a built-in delegate type that C# already provides, and it specifically represents a method that takes one string parameter and returns nothing. Notice, nothing at all, and no return value ever. That's really the defining feature of action, and you can use it with zero parameters too, just plain action like the second example. Or if you need more parameters, you can chain the action string int for a method taking string and int and so on, up to quite a few parameters. Action is genuinely the go-to choice whenever you are representing do this thing, but you don't care about getting anything back. Okay, now actions counterpart for when you do want something back is called func. Let me show you. Func, func, int, oops, int, int, add equal a, b. These are parameters that we are getting, and then we are returning a plus b. Okay, int result equals add 2 and 3 maybe. Okay, console. 5. Func string int greet length text. Length text, and then we're gonna here text dot length dot redline get length greet length. Oh no, greet length. Let's call it get length. Okay, get length of maybe hello. Okay, let's run this. Okay, it's returning 5 as we add the 2 and 3, and then returning 5 as the length of the text. Yeah, this one trips people up a little at first, so let's go slowly. Okay, with func, let's look at here. With func, the last type listed is always the return type, and everything before it is the parameter. So func int means take two ints as parameters and returns an int. Func string int means takes one string, returns an int, which is exactly what getLength does, taking the text and handing back its length. Honestly, this pairing action for no return value, func for has a return value, covers the overwhelming majority of situations you'll ever run into. You'll rarely need to define fully custom delegates like we did at the very start of this lesson once you know these two exist, okay? Okay, now you've actually already seen the syntax a couple times in the last few minutes, the little equal sign and arrow, yes? And I've been sort of glossing over it. Let's probably properly slow down and explain it now, because it's honestly one of the most useful little tools in modern C#. It's called a lambda expression. Let me show you example for lambda expression. Int square int number and return number times number, yes? And func int square lambda equals number number. Now let's try it. Console.writeLine square 5 console.writeLine square lambda 5. Okay, so number and arrow and equal and arrow sign and number times number here. Think of that arrow as basically meaning goes to or becomes. So this whole thing reads as given some number, produce number times number is a completely anonymous, unnamed, a little method. We never gave it an actual name like square. We just wrote the logic directly in line, find assigned it to straight into our func variable. This is genuinely just a shorter, more convenient way of writing small methods, especially when you don't need to reuse it elsewhere by name. And honestly, once it clicks, you'll find yourself reaching for constantly. Okay, and let me show one thing also. Func example, func int bool, look, is even, yes, and then number, oops, number divide by 2 equal 0. Opa, oops, it's even equals it pointing to this number. Yeah, right. Also, right line is even, then maybe 4. Action string out equals message console.writeLine message to upper. Okay, out low. Okay, so let's run this. True and hello. Yes, quick note, when there is only one parameter, look at here, like number here, and the parentheses around it are actually optional. You'll see both styles here. You'll see both styles in real code, number, equal sign error, and inside the parentheses totally interchangeable, just a style preference. Okay, so you can do like something like that. Okay, it doesn't matter, but whenever you have only one parameter, it's optional to wrap in the parentheses or not. It's your choice. Now, everything so far has been a single expression, one calculation done and returned immediately. But what if the logic inside your Lambda needs more than just one line? Let's show me example for that. Func int string describe number. Describe number. Oops. Describe number equal number, and then if number turn even, else turn odd. Okay, let me run this. Okay, odd and even. So when you need multiple lines, you just wrap the whole thing in curly braces, exactly like a normal method body, and use return explicitly. Same as always. Honestly, once a lambda starts needing this many lines, some developers will actually argue it might be clear as a regular named method. Instead, lambdas really shine when they are short and focused. But it's good to know this option exists for when you genuinely need it. Okay, last major concept for today. This one builds directly on everything we just covered, events. And honestly, the easiest way to think about an event is a delegate, specifically designed for the situation where something happened, and I want to let other parts of my program knows about it. Okay, so let me show you one kind of practical example with buttons, especially on front end. Class button, public event, action on click. Yep, public void click console dot writeline button was click dot invoke. Oops, on click dot invoke. Yep, yep. And okay. Look at the line public event action on click. Yep, that event keyword combined with action, remember from earlier, that's our built-in delegate type, is declaring that's button class can notify other code whenever click happens without needing to know in advance who's actually listening. And down in click function on click.invoke, that's what actually triggers the event. Running whatever methods have been subscribed to, that's a little question mark before invoke is a safety check. Remember the null conditional operator from a few lessons back, right? It just makes sure we don't crash if absolutely nobody is subscribed to this event yet. Okay. Uh, so how are we gonna use that? Let me show that. We're gonna create buttons instance button equal new button, and then button dot on click plus equals maybe new function, and then console dot writeline handler 1. Something was clicked, button on click plus equal console writeline handler 2. Logging this click. Okay, Okay, so let's run it. Let's run it clear and .NET run. So look at here, there is nothing, right? Why is that? Uh, it's not showing .NET run declaring. Okay, button and click on click button. Oh, I forgot button click here. Yes, button dot click itself. Yep, now that's work. Okay, look at here. Button was clicked, handler 1, something was clicked, and handler 2 logging this click. C, the most important and interesting part, C plus equals, yes? That's how we subscribe a method, in this case, a couple of lambdas to the event. And notice we subscribe it to separate handlers here, and both of them ran when called click. That's honestly the real power of events. The button class has no idea and genuinely does not need to care who's listening or how many things are listening. It just announced, hey, I got clicked, and anything that's signed up gets notified automatically. This exactly pattern is everywhere. Think about the actual UI buttons in real applications or things like notify me when this file finishes downloading. Now you know what's actually happening underneath when you eventually work with things like this, right? One quick bonus thing, not explicitly on today's list, but it flows naturally from what we just covered, and it's worth knowing. Notice, in the last example, our event actually held two methods at once, not just one. That's actually a feature of delegates in the general called being multicast. Let me show you example. Action, mm, three things equal, console, dot write line, hello, okay, then now greetings plus equals console dot write line either greetings plus equals console dot write line hey greetings. Okay, let's run this. Hello, hi there, hey. So a single action variable, but three separate methods chained onto with plus equal sign, and calling it once runs all three, one after another in the order they were added. And it just as naturally we can remove one using minus equal if we no longer want it to run. Genuinely useful in real applications where, say, a user closed a window and you want to stop listening for its click events to avoid running code on something that no longer exists, okay? So to put everything we've learned today, let me show you one example. Maybe we have class order, public, event, action, maybe string, and then on order placed, on order placed, okay? And public, void, place, order, string, product name, console, dot write line, processing order for product name, product name, and then on order placed dot invoke product name. Okay, that's done. And then we're gonna have here order equal new order, and then order dot on order placed plus equals product, and then console dot write line maybe sending confirmation email and order dot on our place plus equal product console dot maybe notifying warehouse. Yes, notifying warehouse. Mhm. And then order dot place order laptop maybe. Okay, done. And let's see output. Okay, processing order for laptop, sending confirmation email and notifying warehouse. Here. Okay, and here's a nice realistic example. An order class raised an event whenever orders is placed and two completely separate lambdas subscribe to it. One stimulating and sending email and one simulating notifying a warehouse. Order itself has no idea these things are happening. It just announced the event and everything subscribed reacts independently. This is honestly really common real-world pattern for keeping different parts of an application loosely connected rather than tightly tangled together. So that's for all for today's lesson. And at the end of the lesson, I'm gonna give you one channel, which is that creating a class called a timer with an event called it on timer finish it of type action, add a method finish that triggers the event. Subscribe two different lambda handlers to it, one that prints timer done, another that prints notifying user and something, and call finish to see the boss run. Okay, so today we covered a lot defining and using delegates, the built-in action and func types, lambda expressions, both single line and multi-statement, and finish it with events and subscribing to them. Plus a bonus look at multicast delegates. This is genuinely one of those lessons that might take a rewatch or to fully settle in, but it's foundational. You'll see these patterns constantly once we get into LINQ, which is actually coming up soon. Next time we are covering LINQ basics, using everything we just learned to filter, transform, and query collections in a really elegant way. See you there. Take care.